This slide provides a technology overview of the systems at the Bexar County Justice Center. Solar panels on a roof going through a combiner box, then to a DC to AC inverter, then onto the utility. The module used in this project was a Sharp 240, has a 25-year warranty. It was used throughout both sites with over 1,000 units. This slide illustrates how the solar panels were wired at each location, both the series and the parallel techniques, as well as the grounding techniques recommended by Sharp, the manufacturer, that was used in the next component in the system was a junction box that was wired at the end of each string that had a positive, negative, and the grounding connectors all coming in and then running from there in conduit. From the combiner box, the positive and negatives and the ground were all brought into an Eaton disconnect, 600 volt disconnect. An open view of the disconnects shows several of the safety features, as well as the positive, negative, and grounding positions, and also the correct. In the DC disconnects, the array is then combined at a string combiner at each location. These combiners were 6, 12, and 24 volt circuit and were manufactured by combiners. The positive and negatives are then taken to the inverters. In this case, we're showing a PVP 30 kilowatt. Two of these units also included at the new structure was also a PVP 100 kilowatt inverter, which is illustrated here in an open position that shows some of the features, advantages, and benefits. This unit was also used at the existing. The last inverter used at the location was a Selectria 13 kilowatt inverter. It is showed here in a closed position and then here in an open position that shows you some of the parts and pieces that make up this unit. This is the actual view of Bexar County, the rooftop. This illustrates the solar modules used in the project. This is a junction box that comes off the solar panels, then running in conduit up to the actual DC disconnect. You see the conduit then running up into the combiner box, and then the conduit running from there on the left hand side that actually goes into the inverter room. This is an internal view of the combiner box. This shows you the string labeling. This is actually from the roof. This shows an illustration of an inverter in a housing. This is inverter number 2, a PVP 30 kilowatt inverter. This shows you a close-up of the display that'll show your readings that'll determine if the system's operating properly. This is an actual junction box from the underside of the panel. This view we're about to see will show you what it looks like underneath. This shows the solar module cables running, being clipped together by an MC4 connector. More ground wiring, also a tie-wrapped MC4 connector. That's a grounding lug underneath one of the Sharp 240s. Shows you the grounding wire. Bare copper that's been tie-wrapped to the panels. More illustration of the bolting and the I-beams on the new building. That is an actual junction box under the panels on the new building that shows you the positive, negative, and ground, and then leaving in conduit heading to the DC disconnect. These are the actual DC disconnects. This is where we will determine voltage and also current. This should only be done by the electrical contractor who actually performed the work or a qualified solar installer. These are actual DC disconnects with a combiner box on the left hand side. portion of the video. This should only be done by the electrical contractor who performed the original work, but it shows testing points in each DC disconnect. It also shows you meter readings that can be done to determine system performance. This is an example reading of a string, and then also an open view of the inverter.